Good morning, Mishler Math students, and today we're going to develop conjectures about special quadrilaterals, parallelograms, rectangles, and rhombuses. What we're going to do is we're going to try a couple things here and there. I'm going to show you some stuff on GeoGebra, and we're going to use, I think, straws in class, straws and strings. We're going to see if we can create things with using certain measures and stuff like that. Now, look at what these guys are doing right here in this picture, okay? You notice that they're stretching a tape measure across the corners of a rectangular form here. Now, what they're doing is determining whether you've got a rectangle here or not. This has been used in construction for centuries, ever since thousands of years, ever since the Egyptians built the pyramids. And still being used today. People use it all the time. I've done construction work, and this is exactly what I've done. Stretch a tape measure across corner to corner, and if the two measurements are exactly the same, then you know you have a rectangle. And that's a great way to check that. So we're going to do, look in the next section here. It says Activity 1. What does it take to make something? What does it take, for example, to make a parallelogram? Can you just get one pair of opposite sides of a parallelogram to be congruent? Is that going to make a parallelogram? Well, let's take a look and see. Okay, as you can see here, I've written at the top, if one pair of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. We want to see if that's true or false. So I've constructed one side here which is 5 centimeters long, another opposite side which is also 5 centimeters long. So I've met the condition that it says to meet if one pair of opposite sides of a quadrilateral are congruent. So that's true, right? So let's make a quadrilateral out of that by attaching these two sides, or creating these two sides. Now this certainly looks like a parallelogram, doesn't it? If I move this around, sure enough, that looks like a parallelogram. So does that mean that this statement is true? Well, let's see. In order to make this statement not true, all we'd have to do is provide one counterexample. A counterexample would be a pair or a quadrilateral with a pair of opposite sides that are congruent, but it's not a parallelogram. So let's see if we can create that out of the components we have here. How about this? Take a look at this. You see both pairs of opposite, or this pair of opposite sides is still congruent. See, this is still measures 5 units, 5 centimeters, and this side measures 5 centimeters. Now, is that a parallelogram? Well, of course not. That's not a parallelogram. So what I've done now is I've just created a counterexample. And that's what I need to do. When I make a statement like this, it's either true or false. And if it's false, I have to create a counterexample. Okay? Let's try another one. Now we're going to skip down to part 3. You guys are going to do parts 1, 2, and 3 in the textbook. We're going to go through each one of these conjectures, and you're going to prove or disprove, or you're going to either decide whether it's true or false. And if it's false, you have to provide a counterexample. So then we're going to look at this. Look at part 3. It says, what does it take to make a rhombus? Now there's a statement here, number 1. If one pair of adjacent sides of a quadrilateral are congruent, then the quadrilateral is a rhombus. Now we need to decide whether that's true or false. And so I've written up here, if one pair of adjacent sides of a quadrilateral is congruent, then the quadrilateral is a rhombus. And once again, I've done a thing here where I've figured out whether this is can provide all the component parts and see if we have a rhombus. So let's see. There's a side that's 4 centimeters long. Here's another side that's 4 centimeters long. So we've got two adjacent sides. That means they're next to each other. And it's a quadrilateral because I'm going to make another 2 sides here. Now, does that quadrilateral look like a rhombus? Of course it does. It looks just like a rhombus, doesn't it? It's a parallelogram, and the 2 sides here, adjacent sides, are congruent. So does that mean that no matter what I do, when I have 2 adjacent sides of a quadrilateral that are congruent, then I end up with a rhombus? Is that true? Well, like I said, let's find a counterexample. See if we can create a counterexample. And that's pretty easy here, isn't it? Now, is that a rhombus right there? Of course not. This side isn't 4 centimeters long, and this side isn't 4 centimeters long. So we don't have a rhombus there, but we still have we have one pair of adjacent sides that's congruent. But it's not a rhombus. So this, of course, is a counterexample. Now that's what you're going to do when you're doing this project, even though you don't have use of GeoGebra today, because unless you open your computer and use that. But what you're going to do is you're going to create a counterexample for each one of these things, unless, of course, it's true. So when we go through the book, and you do part 1, 2, and 3 on activity 1, you're going to say, what does it take to make a parallelogram? You're going to go 1, 2, 3, 4, and 5, and you're going to answer all these questions. And if it's false, like it says up here, if the conjecture is false, prove that it's false by giving a counterexample. Okay? And then we're going to go on and talk about the house builder theorem, but that's what we're going to do at first. Okay? And that's all I have to say for you. Thank you. Bye.